we want to start looking at inverse variations, which involve putting variables in the denominator. But we'll start by looking at instead direct variations. So since our objective will be that I know the basics of inverse variation, let's understand what a direct variation is first. So the basics are here that the form of a direct variation is y equals kx. Now, when we studied linear equations, oftentimes we used, instead of a k, we used m for slope. It is slope, k represents the slope, but to be consistent with what we're going to use k as the constant for inverse variation, we can substitute it in here, where k is the constant of variation. So the idea is if k is a positive, we're going to assume it's a positive number. As x goes up, the y will go up at that constant rate, the same rate, the rate that slope outlines for us in the problem. So the graph of a constant of a direct variation is just a line through the origin with the slope of k. So it has a y-intercept of 0, but it has a slope of k. Now, let's talk about inverse variation then. Inverse variation is when we take that same idea and we put instead the variable in the denominator. So it's k over x rather than k times x. So this is multiplication. This is where we divide by the x instead. So another way to look at this form is if we multiply by x on both sides, we can get that x out of the denominator, and then we could say that the k equals x times y. If you multiply the x and y values together, you'll get that constant. So k also here, k is the constant of variation. So this k and this k, same k for these, that's the constant variation. But in this case, as the y varies inversely as x goes up, the y is going to go down. So that's what it means by going inversely. As long as we're dealing with, in this case, a constant variation that is positive. Now, let's do some examples. Example of this might be, for instance, y equals 50 over x, where our constant is 50, and we divide it by our x value to get the y. Another way to write this one is multiply by x on both sides, and you get that 50 equal to x times y. Now the basic graph for an inverse variation, where we're just looking at this at an initial stage, is what's called a hyperbola. It's going to be a graph that slopes as x gets positive, going in this quadrant, x gets positive, the y is going to go further negative. Same thing here in this quadrant, as x goes positive, notice that the y is sloping negative. Now it curves in these two quadrants here. That hyperbola is the basic graph of an inverse variation. That'll come up more later as we look at rational functions. Okay, let's do some problems dealing with that inverse variation. So if we say that y varies inversely as x, okay, so that's what we're going to start with. Y varies inversely as x. We want to find just in this case, the constant of variation. Well, we're going to use the form that, there's two forms, remember. We're going to use this form here, k equals x times y. So what I'm going to do to get that constant is I'm just going to multiply x times y. So in this case, that's 18 times 12. And when I multiply 18 times 12, I get 216. That is my constant. So in this inverse variation, every two x and y values that you multiply together have to equal 216. That stays constant. Now let's do this one instead. It says it gives me an x and a y, and it says then find an x when this is the y. So there's several ways to do this, but the way that I would recommend is let's find the constant first. Let's go, constant is going to equal 4 times 15. When you multiply those two, you get 60. So the constant in this problem is 60. Now what I do is I say, all right, if the constant is 60, I'll use my formula, constant equals x times y. I put in 60 for the constant. Here I'm going to find x, so that's my unknown, and I'm going to put in 10 for y. Divide both sides by 10 and you get x equal to 6. So that would be my answer when I find a specific x that goes with that y in that problem. All right, and then the last scenario we're going to talk about is, what if it says, is this an inverse variation? Is this an inverse variation? When doing that, what you want to do is, there's several ways to do it. There's ratios you could involve or whatever. We're going to use that idea of what the constant is for this. So I'm going to, using this x and this y, my constant would equal 1 times 80, which is equal to 80. Let's see what the constant is here. Constant is 2 times 40, which is also 80. So far so good. It's stayed constant. This one, 4 times 20 is also equal to 80, and 5 times 16 is also equal to 80. So since the constant is the same for every ordered pair listed, yes, this is an inverse variation. So that's how this one tests out to be a yes. Now this one, looking at it, using that same idea, I mean, there seems to be something constant going on, but don't be deceived by that. Going up by tens, this one's also going up by tens. One thing that you should have a misgiving about is, remember, as the x's go up, the y's should be going down. So that would tell us it's not an inverse variation. Let's check out the constants. 5 times 20 would give me 100. Here, if I do, my constant is 15 times 30. 15 times 30 is equal to 450. These two do not match. And since you don't have to go any further, since they don't match, it's not the same constant, this is not an inverse variation. So you could say no to that. So in taking a step further from the direct variation, where we've done linear equations where you're multiplying by the variable, inverse variations are where you take a constant and divide by the x instead. You set up problems where the graphs are hyperbolas. You can solve problems by finding x's or y's when giving the other value by involving finding that constant of variation where the constant is the x times the y.